since we've had 2 rocket launches, I thought now would be a good time to do a video analysis of one of them. And so I'm going to do 2 video analyses of the Boeing Starliner launch, and I have that up here. I'm going to use Vernier's video analysis software and Tracker video analysis software. And for both of them, I'm going to use Auto Tracker, which I don't normally do. So let's get to it. Let's look at the video first. I have the video right here, and it's important to kind of look through the video and see what's happening. So here's the Starliner rocket on the Starliner spacecraft on the Atlas rocket. I think that's what it's called. And I'm just going to kind of scrub through this and see what part I want to analyze. Because so right here, I can see that it's launching. And this is a really nice view because we're far enough away and the camera doesn't move. And so that means that I don't have to take into account the motion of the background. I can use the background to measure it. So right there, all the way up to there, the camera does move a little bit. That's because of the shock waves, I guess. But that's what I'm going to analyze. Now, I think it's kind of important to scope out your video and see what part may or may not be analyzable and what problems you might have before you start loading it into the program. So let's just see if right here, see right here, that's a pretty cool shot. However, you'll notice the camera is panning out and zooming. So that's not a good, I mean, I could do it, but I'm not going to do it today. I could do that. And then right here, now I have a problem that I don't have a good reference frame for the background. How does the camera move? I can't see the background, well, except for those towers right there. I could get that part. Then right here, I got nothing. Right there, that's good. Actually, that one's pretty good. That one might be fun. This one, technically, you could look at markers on the ground if you know the distance between them and use the known distance between them to determine the height of the rocket. That's pretty fun. But let's just see. That one's terrible. Can't see anything anyway. Okay, but let's just get that very first part. That's what I'm going to do. Okay, so I don't need that. Let's go to Vernier video analysis. So I have this loaded up. This one, if you want, I think there is a trial version, but Vernier gave me a copy of this, a license, so I'm going to use this, and we can compare. And I'll admit, I'm not an expert at Vernier video analysis. I just haven't used it a lot. But let's just go ahead and choose a file to load. I already have it right there. Where did I put it? I put it right there. That was my Rick and Morty video that I did analysis of too. So there's my video. I'm going to load it. Okay, so there we have it. Now, the first thing you need to do in all these videos is to set where you want to start. It's not super important in this particular case, but this little button down here I can drag and see I want to get to where the rocket first starts to take off. Now, I already looked up the size of the Atlas rocket. It's 52.4 meters, and I'm not sure exactly where that distance is from. I think it's from the top to the bottom, and you'll see here you can't really see where the bottom is because it's kind of in that launching thing. So we're just going to guess and be fine. If you want to do a better job, you can do a better job later. So I'm going to set the first frame to right here. Right there, that looks good. Okay, the next thing I need to do is to set this distance scale in the video. And like I said, I looked up the Atlas rocket, 52.4 meters long. So up here I'm going to click System, and it's going to give me these 2 giant balls here. What I can do is just move this to the top and move this one to the bottom. Okay, now I don't know, and I could be wrong. Like I said, I'm not an expert. I don't know how to zoom in. It'd be nice to zoom in on the video and be able to really get that point in the right spot, but I don't have that. So that's 279 pixels, and I can set that equal to 52.4 meters. I could just say 52 and it'd be fine. And so now I have the scale set. Next, not too difficult. I'm just gonna track. Right. Normally, what I would do next is go through and mark a point on the rocket and do it manually, but I'm going to do it auto tracker. So going over here to add, I'm going to add a point, and I'm going to click the track button, and it brings up this auto tracker thing. So what I want to do is to drag this. I'm going to put the tip on the tip of the rocket, and this changes the size of how far it wants to look ahead. I'm just going to use the default settings. Okay. And I want to move that over a little bit. Okay, right there. Now let's just start auto tracking and see what happens. Okay, you'll see it's advancing the frame and marking the location on its own. And there, it stopped because I guess it lost it, and that's fine. I don't want it anymore. And over here now we can look at the graph. We don't really need the video anymore, so let's just make that bigger. And this plots the X and the Y position. I actually don't care about the X position because nothing happened. So if I click this, I can turn off X. And then I can just click over here. Now what I want to do is to fit a quadratic equation to this to get the acceleration. All this data looks pretty good. I'm going to just highlight just that part, even though because I think I'm not 100% sure about the very ends. And over here I have apply a curve fit, and I want a quadratic fit, and apply. And I don't need the data table down there. You can actually change up here. I could set what I don't know, just turn that off. Turn off the video too, I guess. There. And boom, there we go. So this is my quadratic fit, and you'll notice here that the term A is in front of the squared term. So this would be the term in front of t squared in the kinematic equation. So 1/2 A would be this. 1/2 acceleration. So the acceleration would be twice that value. So 8.4. Let's say 8.4 meters per second squared. And that's the acceleration. Looks pretty good. Data fits pretty well. Pretty happy. Okay. And then you could save it and export it and do all that stuff, but I'm not going to do that right now. I'm going to switch over and we're going to repeat the process in Tracker Video Analysis. Here I have Tracker Video Analysis. Now there is an online Tracker Video Analysis. I'm using the Java-based version because I installed it. You're probably better off just using the online because you don't want to install Java. Nobody wants to install Java. Okay. So the first thing I'm going to do is to drag the file in here, the video file, into Tracker. It takes a second to load. Okay, there it is. And again, I want to set the start of the video frame that I want to analyze. So I'm going to scrub forward. Right. I want it right. See, now I can see the bottom of that. So over here you can see a frame. I'm on frame 362. You could drag that little bar over there, but I like to click this video settings window and type in manually 362 and then click OK. You can set an ending frame too, but I don't really care about that. Next, I am going to set the scale just like I did in Vernier. So that's with this little toolbar up here, show or hide. I'm going to click New, Calibration Stick. And it brings up this little stick. It's very similar. And I'm going to put the top right there. I'm going to put the bottom down there. And now I will show you what's different here. I can zoom into, let's say, 200% if you really wanted to. And I could make sure that that's at the very top and at the very bottom. But the bottom's ill-defined in this case, so again, we're going to be having a problem. And now I'm going to click this and change it to 52.4, and that will be my distance scale. Let's go back to fit. Okay. Now I can move this stick off. I didn't show it in the other one, but you can set your coordinate system. The coordinate system's right there. It doesn't really matter too much. We're looking at a change in position, so it doesn't matter what the position is. Okay, let's go ahead and create a new track. I'm going to click Track up here, New, Point Mass, and then it's going to set up all the stuff for the point mass. Now, if I click on the point mass, which is called Mass A, you can change the name of that if you want. I'm going to click on that and go to Auto Tracker. And it's going to bring up this Auto Tracker window, and it says right here, to create a new keyframe, Shift Control click on the video of interest. So let's go Shift Control click. Let's go ahead and zoom in back to, let's say 200%. So Shift Control click right there at the top. There. And you can also adjust the window through which it looks for new things. I'm going to leave the default settings. And now I'm just going to click Search, and it's going to look for the next location. Okay, so it stopped. Let's see where it stopped. Okay, it stopped because the thing went out. So that's good. So we'll click Stop. Okay, and now we're done with this. So I can close this window. And here we have our X values and our y values. That looks very nice. So I'm going to right click on this and go to Analyze, and it will bring up the curve, y versus time, and then Analyze right here, Curve Fitter, Parabola. You want a parabola, and it fit a parabola to the whole thing. If you don't want that, you can highlight. I think the whole thing's fine in this case. So over here, ooh, that's weird. Over here, I have my A term is 2.7. So the acceleration is twice that. Why am I getting off by a factor of 2? That's weird. Did I set the scale wrong? 52.4. That looks right. Why am I getting a different value? A is 4.23. Let's see. 52.4, same scale. Let's go over here. The time step is 0.003 seconds. Let's see over here if the time step, it thinks that the video is different time. How do you do that? Let's see. Frame rate, 29 frames per second, so that's the same thing, right? 29. Interesting. Very interesting. So let's just think for a second. An acceleration of, it seems like 8 would be a better acceleration, right? Because you have, if you think of that'd be like that'd be 2 G's. So this one, so I think maybe there's something wrong with this. But what's wrong with this? I mean, it looks fine to me. The scale's the same. Well, let's look at this. Okay, this goes from, I thought this was gonna be an easy video here. This goes from 0 to 45 in 2.4 seconds. And this goes from let's see, the y value there is 102, and the y value up here is 124. So this one doesn't go as high, does it? It goes from it goes 24 meters in not as much time either. Maybe it didn't get all the video. Let's see. Let's see if I just play it. Okay, see that? It stopped right there, right? It didn't get it the whole way. I think I'm tending towards the tracker video analysis. It's more time and it looks a little more consistent. But again, I'm really just showing you how to use these two things. I don't really mean for this to be a big thing. Okay, so I'm going to stop there. I'm going to explore this on my own. You can explore this on your own. You can get the video. You can at least try a tracker video analysis and see what you get for the acceleration. I guess we could look up the acceleration of the Starliner. Let's see if I say, what was the acceleration of the Boeing Starliner? Okay, it didn't say. So that's fine. The end. I'm going to stop there. I know that's dumb, but I'm going to stop there. So, hope you learned a lesson about how things can go wrong when you think they're simple. The end.